Jai Hind to all. My name is Aarti Chaudhary, and in today's session we will cover the layer is transport layer. This is a layer which is used to transport the data from the source to destination. As we have seen that in OSI models, we are having many layers with us. So that is a most prominent layer. We can say it will used to deliver the data from process to process delivery. One of the main functionality of this transport layer is it will deliver data from source to destination, process to process delivery we are having. So we will see that what are the positions of this is a position. It is between the application layer and the data link networking layer. In this we are using a transport layer that is sandwiched in between. So what are the services we can use in a transport layer is the quality of service, what type of quality we will provide to our data. Next is congestion control in which when we have to deliver a data, and data has to be you can say is data has to be overloaded. The routers are overloaded and we are having lots of data. So how can we control this congestion? How we control the data flow of data from the source side to destination side? So there are some measures we can take it in a congestion control. Like what we have is we are having two types of it, that is open loop back and it closed loop back. In open loop back, what we open and close, what we have to do is retransmission. If you are not having a priority data, if the data is not priority, then you will said okay, just stop because there is some congestion. In a real time scenario also, when there was congestion in any area, you will divert the routes. So in same here in the transport layer, what will, if any data, any router is congestion will, and we are sending a message so that is to be done by the transport layer, that is congestion control. In a phase of that, what we have to do is stop. If you are not having a priority message, so you will stop it, and after some delay you will deliver it, or you can resend it, retransmit it. So these types of the congestion control we can use in the transport layer. Quality of service, what types of quality we are having a data, is it reliable, it is unreliable, that the services we will provide it here. That is we can say is connection control. Congestion control is these two types of connection control. We are having a connection oriented and second type is connection less. Two types of connection control we are having in transport layer. First one is connection oriented, in which what we have to do is when we have to send any data to a source to destination, and what we have to do is we have to establish a connection. Before sending a data, what we have to do is we have to send, we will say that I will send a data, so the client will send our data to a list. This is called a three-way handshaking, which we use in transport layer. So what we have a client, we have a server, receiver here, and what we will send it before sending the actual message, what will is it will send it a message, that is a data, you can sync, you will take a sync of 8,000, we will say it. Okay, 8,000 sent to a side of a receiver. Then it is a datagram, it will say is okay, sync 8,001, what we is saying is 8,001 we are having, and then after what we has to do is 8,001 plus acknowledgement. Okay, you are sending a data, I'm acknowledging you by incrementing a sequence synchronous bit as 1,001 bit of it. Next is if it getting it okay, then in synchronous plus acknowledgement and plus data we will send it. Now my data will be sent from the source to destination. This is how the synchronous connection control is to be there. But in that way we have established, this is called establishment of the data. Before sending a data, you will establishment a connection. When we have completed a data, the data from the sender side, receiver side is to be stopped. We have to stop. Then we have to release a connection. And that is a terminate a connection. So how then we will say send a data. This is the last bit of mine. Okay, it will acknowledge you and then it will terminate. This is how the connection oriented work. But connection or less how it is working. It is like when we have to send our data without any concern about any data will receive, any data will be lost or discard. We will not care about that. We will want to send our. So in real time application and multimedia application, we will use a connection less approach. Next is packetization. We will send a packet from a source to destination. We have to packetize it and then after mention all the addressing needs are the reliability. If you are sending in data in a reliable network or reliable network, you will send it by this. So all these are the transport layer applications, transport services we are having is packetization, connection control, reliability, connection addressing, reliability, congestion control, connection control and quality of service. So we will see that all the, what are the duties of that is packetization. In packetization, we will create a packet and then after we will take any protocol which is used in transport layer, that is any TCP, UDP, SMTP, what of the protocol you were using to send the data from coming from upper layer and going to a lower layer. Next, the control, we will see it in our and addressing and provide the reliability. These are the things we will see. So before going to a deep of all the protocols, we will see it. Any header, we will see it. We will see that what is connection less and connection oriented. There was two types of it, either connection less or connection oriented. We will see that. Connection less may protocol layer treat each segment as an independent packet. Every packet which is sending, because we are not sending whole of the data into a one packet. We are sending a small packets. So all packets, all these packets are independent. There is no linking, there is no relationship between all these packets, because there was no any synchronous number of it, any sequence number of it, anything which will identify that this is linked with this. There is no relation into it. So they all are independent to it. There is no relation. You can say is no relation into in the packet key form. We are not having any relationship, and deliver to a transport layer at a destination message. So we are sending a message from the sender side and we will get giving to a receiver side. So there is no linkage of packet. There is no sequence number what we have to write in a connectionless protocol, which is a connection control mechanism which is used in a transport layer, that is connectionless. Next is connection oriented. In connection oriented, we will vice versa of it. We will establish a connection. So we are having our relationship. So it make a connection between our transport layer at a destination machine. First, before delivery of the packet, we will make before sending a delivery, we will numbering the packet. So what we have to do is, this is my packet 1, this is my packet 2, this is my packet 3. How can we identify it? This is, if at the sender side, we will sending it 1, 2, 3. Maybe at the side of receiver side, we will getting it 3, 1 and 2. So how can we identify it? No, this is of 3. Okay, this is 1. Okay, we will assemble it here. Oh, it's 2. We will suited it here. So when we are making our data which is combining at the destination side, what we have to do is we have to make our checking the sequential number. That is a relationship between the packets which we are sending at the sender side and that is receiving at the receiver side. So this is this and this is transferred So before, when we are having a connection oriented, two things you have to mention. We have to send a data, that is most prominent, because we are making a connection to send our data. If we are sending a data in a connection oriented, first thing is you have to connect to our destination first. If the destination is busy, then you will not send data. You will not form a congestion into a network. Network means no congestion will be there. If you know that the person I want to talk is busy, so why were you wasting your energy by speaking something? First of all, you will see that the receiver is receiving or is not, you can say is not busy. Then after, what we have to do is, if not busy, you will establish a connection. Then after sending your data, that is valuable data to it, and then after the destination side, we will getting a data back to it by acknowledging it. So in the connection less, we are not having any acknowledgement procedure, but in connection oriented, that is a acknowledgement process. So it makes something complex to this, but we say that at the end, our data is safe. The data has to be delivered to the destination without any concerns that any data lost is there, any duplicates is there. We will see that. Okay, though all these types are, that is connection less and connection oriented we are having. In a transport layer, we are dividing into two parts. We are seeing that it a connection that is less approach, and this is connection oriented protocol. In this, we are using a protocol that is UDP, user datagram protocol, which is treating every segment separately. There is no connection because they are using connectionless approach. In the TCP and SCHP, all these are the two approaches. We are having a relation between a segment by using a sequence number. So we are having a sequence number 1, 2, 3 in the increasing order. We will see that, oh, this is lower than this, so we will place it and accordingly we will reassembling it at the destination side, and we will get our original message to it. Okay, then this is a fee. So in the other slides, we will see cover TCP or SCTP also, but in the today's slide we will cover the UDP, only UDP. What are the uses of UDP? Why we are using UDP? What's the need of UDP? What is a header? How can we have separate message? How can we combine it at the destination side? Is there any disadvantage of using UDP? What is the advantage of using UDP? We will see in the subsequent slides. Then that is process to process delivery. In the process to process delivery, when any thing we are having have a responsibility of the process to process delivery, the delivery of the packet, the part of the message from one process to another, two process communicate by using a client server relationship. Client is what we are having a sender, and the receiver which we are having a destination we are having. So what the thing that the process to process delivery we will see in our client server parent-ROM, and then we will see that what the widget. So the responsibility of the transport layer is process to process delivery we are having. So in the type of data delivery we will see, up to now we will see that also learn about the data physical layer also, data link layer also, network layer also. When we are going for a transport layer, all three layers will be covered up to now. I think you will covered all that layers. So now what's the thing we are having in our data delivery is, what we are having a processes which is running at the client side. So this is my client, and this is my server. Okay, so client server parent-ROM we are having here. So we are having process which is running here. What is process here? I will elaborate something. If you are having to transfer any TCP, any file from one source to destination. So what we have to do is this process, that is any word file, yeah, any mail or any you can say is any document, any PPT that is running on the client side. is the process running on the client side. Same process is running on the destination side also. That the thing is, the process has to be same process which we are having, because process ki compatibility, that is must necessary here. So that necessary is to be the process P1 is running here, same P1 process, same data type has to be running here also with other name, that is the same data types has to. So the process to process delivery will be seen by the transport layer. The transport layer will be responsible for the process to process delivery. Next, what we have a client, if we are having a node-to-node delivery, which is handled by the data link layer, node-to-node. So we are on the same link and we have to handle a data. Data is transferred from one node to another. The node-to-node delivery is done by the data link layer. If we want to say is host to host delivery, host to host, because in the network layer we are having a IP address. If I saying that if the IP address is source IP address and destination IP address, we will see in a IP layer, IP header layer, header. So we will see the host address and the destination as a, if the host address is initiating and the destination IP address will be getting it. So that is a, we will get a IP here. The IP will be matched here. The IP of the source and destination, which is written in the header form in when we are initiating a message from the data is coming from the transport layer, and then we're going for a data link layer. Then what we have to be IP address that is to be there. The IP address has to be matched from the source to destination. Then after this is called a host to host delivery. So that is most important data delivery we are having. In the node delivery, we have a data link layer. In a host to host delivery, we have network layer, and the process to process delivery that we are having a process transport layer. So, and in this, in the previous slide, we will see that when we are going for node to node delivery, what are the address we are using it. So, when we are going for a node to node delivery, we are using a MAC address here to identify that, okay, this MAC is this, my MAC address. I am giving a MAC address to a data link layer. It is matching a data by using a MAC, which is of destination. If it's that match, okay, node delivery is to be there. That is, so every time the MAC has to be updated up to when we are not getting a IP address of the destination, which is written and earlierly known by the source address. Because we don't know about the MAC of the destination, we only know about the IP address of the MAC destination. So we will have an IP address of destination that is matched for this by using a host to host, but on node to node basis we are only matching the MAC. So we are matching, and every time we are preparing a message, because at the node to node delivery, what we are having, the data comes from source, and then after going from the node to node delivery, only three layers will be there. The first layer is physical layer, second layer is the data link layer, and third layer is the network layer. We will see the message up to the network layer. We will see that messages. Okay, we will see the network layer. No, it's not. The IP address is not matching. IP address is not matching. IP address is not matching. IP address. If up to when we will not get our IP address matching, we will not decrypt the message at any node which is between the network. All the intermediate node, we will not making our data has to be the data has to be what the data has to be matched. The IP address should be matched at the destination side. So then after data will be decrypted. So what is the next we will see it at the host side, that is network layer. What we are having a IP address. Okay, at the process side we are having a port number. So when we are going for a message delivery, we will see the state, then we will see the city, we will see the locality, we will see the number block, and then we will see the house number. So this way we will deliver our letter from one state to other state. Similar here also we are delivering a message from one state to other state, source to destination, by using all these MAC address, logical address, physical address and port number we are seeing. So this is a port number. We are having this is a concept when we are running a process. The process has to be, and this is a port number of 52,000, and the data has to be the data, then after the port number of the destination, that is of 13. So we will write the port number also here, and then 15 region. That message is transferred here, and then after the data has been transformed from that DJIM server to the client also by making a message, your port number, your destination port number, and then after you will give a message to a client also, reverting it back. So what is IP address versus a port number? What we will see that if we are having a IP header here, IP header, we are having a destination IP address. I've seen in the network layer, we will see that the destination. Then we have a transport layer header. Transport layer header, what we are having, what process we have to deliver our letter. So that process have to be delivering our letter to our port number 13. So it will first see the IP address of that server, and then after we will go to that process on that port 13, and then we will see. So IP header having a header of the transport layer also. Sorry. So transport layer ka header we will having when we are combining a message from application to the transport layer, then data link layer, all the headers are to be joined into our data. So we will see the IP address, then we will deliver that to that IP address, that destination, and then after on this destination, what the process has to be selected, that has to be there with a port number of it. So these are the range of the port numbers we are defining into it. So we are having a IANA range, that is Internet Assigned Number Authority. We are having a port numbers of it. So we are having 0 to 1 to 1023. This is the well-known ports we are having. We are assigning on it because 80 port also we are having, 80 port also having, and 101 port also having. These are the well-defined ports which we use in our daily life. In that 101 to 49151, this is a registered port, that is no duplicate seen to be it. So we are having a registered port which is assigned to all the application which we are using into our computers. Then 149.150.2 to 65535, all these are the dynamic port. When we use it, you will assign it and then release it. You want to use it, these are called the dynamic ports we are having. So all these are the next is the what is a socket address. Socket address, when we want to combine a IP address with the port number, we will say that this is my socket address. When we will combine at the receiver sender side, I have an IP address also. A processor initiating any request is have a port number also, and then after when the destination side also we are having a IP where we have to deliver a message, and in what process we will deliver it, we will assign it there. That combination is called a socket address at the source side also and destination side also. So that is multiplexing and demultiplexing. Multiple processes are running at the source side and the destination side also. They all are multiplexed because all are having a port number. So we are having process, then we are multiplex it, then we are having IP, we are going for a destination, and then at the sender side we are multiplexing many to one, and the receiver side we are having demultiplexing, that is one to many we are having it. That is one of the things which we will see that in a network. We will see all the three layers. We really read all the keys. Error control and flow control, this is a thing we have to discuss in every layer. Error control, when we have to deliver any message into a network, that message has to be authentic or not, there is no delay into it, there is no duplicacy into it, anything changes into it, any corrupt message will be sent to it. So all this error control we have to see in our network. And the flow control also, the rate of sending our data from the source side to the destination side is to rate of absorbing our data is to be matched. If it is mismatched, so it will create a flow control. The data will be lost, the data will be duplicated, we have to retransmit it with the acknowledgement, we are not getting acknowledged, all these problems we have. So every layer has to be flow control and error control. So all these things are at the transport layer. We are if it's a blue mark, black mark, sorry, so it is error is not checked in these path by a data link layer. But when we are having a error check at this point, all this point, we are having a data link layer. There was a mechanism of error control and flow control, that is CRC, checksums, LRC, VRC, all these sections are we are having. Error correction and detection has to be there. And what we are having in flow control has to be done by what, sliding window protocol, go back in and stop and wait. All these are we are using into a data link layer. But at a transport layer, no internal, only internal flow control and movement, but not external control what we used in our data link layer. Definitely we are having a, if we are using a connection less, we will definitely have a checksum of that, the header is not corrupted and all that, the data. When we are connection oriented, that is a flow control and error control mechanism we will have. So when we are having a link node to node, we will have our error control. But when we are on the same plane, we will not have a error control into it. Next is connection oriented and less or connection oriented services. We know that. So we will see that connection oriented less is the packet are sent from one party to another. There is no need to no need of for communication, no need of connection for the establishment or a connection release. We will not make up that connection has to be there or not release any connection because we have not created any connection. The packets are not numbered because they are, so there maybe has to be, so here disadvantage will be, there will be not having a delayed and lost or maybe arrive at a sequence, because we are not having a sequence also, we are having a delay also, we have having a lost packet also. All these problems will be occur when we use a connection less approach. So we will shortly see that one of the transport layer protocol is to be that is UDP, that is it is connection or less approach. Next is connection oriented service. In this connection oriented service, the connection is first established between a sender side and receiver side, and data are transferred at the sender. The data is transferred. So at the end of the connection, we will release the connection. So we are having a connection establishment also, data transfers also, and connection release also. So these are the two protocols we will use here, TCP or SCTP. We are the two protocols we will see in a transport layer. Reliability and unreliable. You will see that if we are having a connection oriented approach, like we will establish a connection, then after data is sending, and then after we will releasing a connection. So there was some probability that the data is reliable. The connection is reliable, or we were sending a data also, we will having authentication that data is received or not, delayed or not, or retransmit or not, lost or not, we will getting information about that. So this is make a reliable here, but unreliable when you're not getting any data information about it, so that is called a unreliable. So this is a reliable in which the application layer we have a reliability, where reliable by making a flow control and error control at this. So when we are saying that it's reliable, it is having a flow control and error control at the side, but it makes our disadvantages slower and more complex service. When we are making a connection oriented approach, we will making it reliable, but the slower and more complex services was to be. On the other hand, if application does not need reliability, they don't need it. They don't need that my data has to be be transferred or not, I get information about it. They don't need it. So they will have, because it uses its own flow control and control mechanisms. It is inbuilt into it. So we have to need a fast service in a nature. So we will use that. We will not use your error control and flow control. I will use mine flow control and error control. So real type application, that is multimedia transfer. When we have transfer any buffering a data or anything real time application, we will see that the flow control and error control has to be there, but the reliability networks to be there. This is a position of TCP, UDP and the SCTP in TCP IP suite. We are using it because OSI model is a reference model. The TCP IP model we are using to our notion. So this is a network layer which are having a LANs, WANs and all the error control mechanisms we are having. We are having IP version 4 and version 6. We are a ARP to get a MAC address and the RVRP and this. So we are having a TCP and UDP here, in which this is our UDP, in which UDP is a connectionless and this is my connection oriented approach. Okay, then we are using a user datagram protocol. In this, we are having a connection-oriented, unreliable transport protocol, and we are using process-to-process delivery. We are having. So all these, what is a powerless? What you can use it. Why we are using it? When we want our data is to be not much secure and we are sending a small information, small messages, so we can use it. We want a less interaction between sender and user, so we will use a UDP approach. That's the need of using it. So all these are the well-known ports used in UDP, eco ports, TCP IP ports. These are the inbuilt 7 we are well-known ports. We are having these UDP ports into it. So this is a header length. This is the header length. This is a 16-bit port length, destination 16-bit. It is a total length and the checksum. Checksum is inbuilt into it because we are not any external error and flow control into it. So all these are 16. So UDP length is equals to IP length minus IP header length. That is the formula we are used to calculate the UDP length. So this is a stereotype how to calculate we are divided into 3 types, that is header and the data which we have. So how can we calculate that my data has to be at the sender side to receiver side, my data is not corrupted? By using this checksum we can use to calculate it. So these are the operation we can use by using UDP, that is connectionless services. Any services which is connectionless, no establishment, no data, small message you have to send it, independent message you have to send it. You can use a connectionless approach. UDP is used for it. Error control, flow control, it is having a inbuilt checksum, a 16-bit message into it. And if we want it, if there is no external flow control and error control we want it, so we are having a checksum. We can check that my header is corrupted or not. Encapsulation and decapsulation we will use into a UDP or TCP UDP operation. So that is queuing into client key side you have an outgoing queue, and then after at the incoming also we are having, because lots of messages are coming because there is no connection establishment to it. So we have to be queue concept here at the UDP side, outgoing queue and incoming at the both sides, sender and receiver side. So these are the uses of it. It is used for simple client to server communication. There is no concern of flow and error control, and we are using want to send a bulk message, we are using a FTP. We are using internal, not internal. We are having a checksum here, so we will use our trivial FTP here with the error flow control. We are simply using it. In the multicasting we are also using it. So we are having a software of it. We are using a simple mail transfer protocol. We are using UDP here, and in our routing updating techniques at RIP we are using a UDP message that is used here. Okay, so all these are the uses, headers, and what is the advantage and disadvantage of using a UDP here. Okay, thank you.